Hello students, let us see one example where inverse Laplace transform we need to find out. That is, already excess is given and three conditions are given based on region of convergence. So in Laplace transform, what is region of convergence? Basically, it is the set of the values of the complex variable s for which Laplace transform converges. So meaning is that whatever value of s we are going to uh, apply or we are going to use whenever this transform is used for some applications in domain mapping, after domain mapping rather, then at that time, either for designing stable system or a system with causality or whatever is our requirement, so at that time it should be a kind of convergence is to be taken into consideration, and we are going to treat it as one of the very useful parameter in complex S plane. Whenever we say that this particular function f of t or x of t is converging for these set of values of s, so at that time it is giving us idea or it is helping us while handling the actual design of the system in contrast with stability and other parameters. So region of convergence is very, very important from that point, because whenever it is not converging, at that time probability of becoming that system unstable is very high. So for designing stable systems, ROC is very, very important fact. Now let us use this actually whatever they have given the conditions, and accordingly let us simplify. For us here it is a numerical simple, not any particular system we are designing. So the expression given is xs is equal to 3s plus 7 divided by s square minus 2s minus 3, and the region of convergence conditions are, first condition is RES, that is region of convergence, is greater than 3 for s value, is less than -1, and third one is range is given -1 to 3. Now for all the three cases we will solve. So before that, let us first of all find out the function which we are getting with this excess. Now standard procedure is, for finding inverse we are using partial fraction expansion, and first of all we need to identify the poles of the system. So our expression is xs is equal to 3s plus 7 divided by s square minus 2s minus 3. So 3s plus 7 as it is, and the denominator we are going to factorize, find the factors. So s square minus 2s minus 3, the factors are minus 3 and 1. So s minus 3, s plus 1, these are the two roots. S is equal to 3 and s is equal to -1. Now what we do in partial fraction expansion method or PFE method, which is very, very useful technique used in inverse Laplace transform, inverse Z transform. So many times we can use this in residue method also. It is associated technique. So here we are writing now the factors. So coefficient is K0. We can write here A upon or B upon or A1, A2, C1, C2, whatever mnemonics you can use. For example, I am using here first fraction corresponds to the coefficient K0. Second fraction corresponds to coefficient K1. So our K0 divided by S minus 3 is first term, and K1 divided by S plus 1 is the second term. And now what we need to do is, based on this, we want to simplify. So first root is at S is equal to 3, and second root is at s is equal to -1. So our formula is, whatever is this root, we are going to take it as it is. While finding the coefficient, formula is that root into excess at the value s is equal to that particular root. So first of all, we'll let excess is 3s plus 7 divided by s minus 3 into s plus 1 and multiplied by s minus 3. So s minus 3 will get cancelled, and remaining is only 3s plus 7 divided by s plus 1 at s is equal to 3. So here s is equal to 3 we will substitute, then 3s plus 7 divided by s is equal to 3, 3 plus 1. Here it is 3 into 3, 9, 9 plus 7. So 16 divided by 3 plus 1, 4, and therefore total it is coming out to be 4. In second case, second coefficient K1 is equal to s plus 1 into xs, that is 3s plus 7 divided by s minus 3 into s plus 1. So out of that s plus 1 will get cancelled, and remaining is only 3s plus 7 divided by s minus 3 at s is equal to -1. So here we are going to substitute s is equal to -1. So denominator is becoming -4 and numerator is 3 into -1, that is -3 plus 7. So it is -4. minus 3 plus 7 minus 4, and here it is also minus 4. So it is coming out to be 1 minus 1. So therefore the total here we will simplify as xs is equal to 4 upon s minus 3 and minus 1 upon s plus 1. Now these are the two roots, and accordingly Laplace inverse. Suppose first case it will be 4 upon s minus 3 is, we know 1 upon s minus a is e raised to at or ax. So that is at now, it is in time domain we are treating. So 1 upon s minus a inverse is e raised to at. So here a is 3, this 4 as it is. So e raised to 3t into ut minus e raised to minus t, e raised to minus t s plus a. So it is e raised to minus at. So in the denominator, if it is s minus, then the e raised to will be a plus, and denominator is s plus a, then the e raised to inverse will be e raised to minus a. So remember this, Laplace transform of e raised to at is 1 upon s minus a. E raised to plus at corresponds to 1 upon s minus a. E raised to minus at corresponds to 1 upon s plus a. So accordingly, Laplace transform is considered here. Now for second case and same fashion, we have written the expression. Laplace inverse for second case is same fashion we have written. Only the thing is region of convergence they have given as less than a. So whatever is our value, what is the smallest value? Minus 1. So accordingly, we have written here minus 1. And in this case, for first case, they have given the value RES is greater than 3. So therefore, here region of convergence, we are saying sigma or RES we can call it. So that is greater than 3. Here it is less than minus 1. And in the third case, they have mentioned it is minus 1 to 3. So therefore, our roots are poles are at s is equal to 3 and s is equal to minus 1. So s is equal to minus 1 if left side of ROC, and hence the term corresponding to this ROC will be right sided. So that is region of convergence is greater than minus 1, and this total will be, the poles are, one is here and another one is here, and accordingly we have shown the region of convergence. Similarly, the pole at s is equal to 3 is to the right side of ROC, hence the term corresponding to ROC will be left sided. So this is the region where our actual convergence is going to be taken into care. So this way you can have the expression and you can find out. Now one more example just I am taking here, inverse Laplace transform. You can see expression is 3s square plus 8s plus 6 and the roots are s plus 2, that is the pole. Second term is s square plus 2s plus 1. So here what we can do, this is a complete square of s plus 1 square. So 3s square plus 8s plus 6 and divided by s plus 2 s plus 1 square. Wherever there are three total poles, one pole is s plus 2, second pole is s plus 1. The practice is whenever there is higher order pole, so that is first order pole, then only one term. If it is a second order pole, then there are two terms or two factors, and in PFE two fractions. So first one is s plus 2, and here for raised to 2 we are going to treat two factors. First one is denominator s plus 1, that is the first order, and second one will be nth order, that is the second order. If there is s cube, whatever is the term raised to 3, then accordingly 3 fractions. So like that we have to simplify. So same style, first of all a coefficient we want to calculate, then a. So for that, whatever is the denominator s plus 2 multiplied by xs at s is equal to minus 2. Substitute this, simplify it little bit, you will get particular value of a. If you substitute here s is equal to minus 2, this expression and this expression. In case of coefficient b, it is formula is 1 upon whatever is that root, ordered root factorial d ds of s plus 1 square and xs at s is equal to. So what is that? S is equal to minus 1. So if we substitute all this, accordingly b is equal to 1. And same fashion for c, it is a direct calculation, s is equal to minus 1. And therefore we are getting terms 2 upon s plus 2, 1 upon s plus 1, 1 upon s plus 1 square. Now this is for s plus 2, it is 1 upon s plus a is 2. So e raised to minus at, e raised to minus 2t, u of t, no doubt, and this constant is coming out to be, coefficient is coming out to be constant for the multiplication. Then e raised to 1 upon s plus 1, that is e raised to minus t into ut, and the third term will be, this is s plus 1 square, and therefore it comes out to be t into e raised to minus t ut according to standard Laplace transform pair. So this way it is to be solved.